It's not a poem. Today, I'm going to teach you Boolean operators in Python. We are going to start with the basic knowledge about the truth value of objects. Let's say if you evaluate a variable or an object for a logical value, what was the outcome? Next, we will learn about the set of Boolean operators, which is composed of an operator, or operator, and not operator. These operators allow us to derive the truth value of one or more operands. We also cover any and all built-in functions that allow us to successively evaluate a set of logical values. So, what's actually the truth value? The truth value is of an object could be one of true or false. An object could be tested for their truth values. By default, an object is considered true unless the class other define others. So, as I mentioned, by default, every object is evaluated as true. So let's see the examples. Let me start with define a function for testing the variable's truth value. So this function basically print out the input argument's truth value is true when the argument is evaluated as true, and otherwise it prints the input argument's truth value is false. Okay, let's run this cell. So we already defined the function, right? Let's start with the truth value of a non-zero numeric variable. In this case, I will test the truth value of 1 and minus 1.5. Let's see what is the result. Okay, as you can see, both evaluation returns true. Next, we will try to evaluate the truth value of a string. In this case, I will try to evaluate the string true and evaluate the string false. Do you want to guess what's actually the result? Okay, let's see. So, some of you probably surprised why when we evaluate the string false, the truth value of it is true. It's because it's just a string. So any non-empty string, truth value is true. Okay, let's continue. So now let's see what is the truth value of the true constant here. I think it's pretty simple, straightforward. It's true. Okay, and what about collections? So let's evaluate the truth value of a list, a dictionary, and a set. So you see, if these collections are not empty, it always returns true. Then, what if we want the truth value of false? What kind of object returns truth value of false? So there are basically three types of object that returns truth value of false. The first one are non and false constants. So when you evaluate the truth value of non and false constant, it always returns false. So let's see the first cell here. Yeah, both of them return false. Yeah, we are the truth value of non here and evaluate the truth value of false here. Both of them is false. Okay, let's continue. The next case is the numeric type object, which hold the value of 0. So it could be either 0 integer or 0 float. Both of them will return the truth value of false. Okay, keep going. So the last case is the empty collections. So when you evaluate an empty string, an empty list, empty tuple, or deck, empty dictionary, empty set, or even an empty range, all of them will return the truth value of false, just like this. So we start with an empty string here using only single quotes, then return it to double quotes. The value are still the same. And let's go further. We have the truth value of an empty list, an empty tuple, empty tick, an empty set, even an empty range. So for an empty range, we define like range 0. So basically it's like return the integer from 1 until 0. Sorry, from 0 until 0. So in this case, there is no such integer, right? Because 0 until 0, there's nothing there. Okay, so I believe you all are more familiar with the truth values of the objects in Python. Next, let's see the Boolean operators. So the Boolean operators are used to evaluate the truth values of one or more operands. Most of you who has learned mathematics before should be familiar with these logical operator like OR and AND operators. For not, you can see it's like transform the truth value into the opposite side of them. For example, for x or y, it returns if x is false, then y, otherwise is x. For x and y, if x is false, then it returns x, else y. For not, it is used to convert the operand into the opposite side. For example, if x is false, then not x is true. So next, we'll see about the priority of evaluation. So basically, the priority of evaluation is going in the list from not and then or is the last priority of the Boolean operators. For example, if we want to evaluate this statement, true or false and false, as I mentioned, it's going to evaluate not first, but in this case, we don't have any not in this statement. Then it will evaluate and. So you can imagine some kind of parenthesis here. So false and false return false definitely. And finally, it evaluate or. So in this case, it will evaluate false and false first, and then followed by or this one or. So it's going to be like true or false. So let's see. So it returns true, right? And if you want to make it explicit, so you just add the parenthesis here, and then you evaluate this statement. Yeah, it's got the same result. If you want to prove that, okay, it's evaluate and first, you just prove by negate this statement. So you add the parenthesis here. So you force it to evaluate all first, right? If you do it this way. So you see, the result from this evaluation is false. So this can show us the sequence of operators that has been evaluated. And in every case, it always evaluate and before or. Um, for the another thing about and or operators is there are something called short circuit. So if it's already known what actually the result, it's not going to continue evaluation. Let me explain you a bit more. Like to show you this, I think we need to define another two functions. The first one is evaluate true. This function will print out when it's called. It will print out these strings like calculating functions evaluate true. So we know that this function has been invoked, right? And finally, it will return the value of true. And we also define the counterpart function for false as well, called evaluate false. So when this function is invoked, use it will print the string like calculating function evaluate false and then return the value of false. So what is short circuit? So let's say you want to eva- evaluate the statement that consists of an operator. If one of them is if one of the truth value is false, it always returns false, right? Like basic logics operators, like false and true is always false, and or false or anything is always false. So in this case, when you evaluate this statement, like evaluate false and evaluate true, so it's gonna be like this one is will be evaluated as false, right? And this one will be evaluated as true when you run this function. Uh, no surprise. Oh, sorry, I forgot to run this cell first. So no surprise, it's gonna return false, right? But what actually I want you to look at is like this this statement is evaluate just only the first function, right? So it prints just only this statement. So we never touch this one. But what if we shuffle the sequence of evaluation by evaluate true first and followed by evaluate false here? So when you run it, you see that both of the functions are revoked here, right? Let's start with the calculating functions evaluate true, and then it revoke the evaluate false function here. So it prints out the calculating function evaluate false. So you can see that the final outcome are the same, but the process are a bit different. For this one, it stopped after it knows that one of the input is false. So false and anything is always false. But for this one, the first one, you evaluate true here. So there could be both cases these statements are because so if the first one is true, when you need to check all of them about the final outcome. So when this one is false, the final outcome is returned false. And it's same for the operator as well. Let's say one of the input is true. It does stop the evaluation and then just return true here. So in this case, I think we can guess that it's gonna evaluate just the first function. And vice versa, if we swap it by evaluating false first, it's gonna run both functions. Okay. So let's say if you want to test a bit more, like if you have kind of like three evaluation here, like you want to evaluate um, false here or evaluate, then followed by evaluate another false, and then end it evaluate true. So I think you can imagine that these three functions will be evaluated. So it's gonna print like evaluate false, and then evaluate true, and return the result of true. But same if you start this with evaluate true first. So I copy this first. The first one will return true, right? And it's gonna short circuit of the whole statement. So it will evaluate only true and then return the value because it knows whatever it evaluate next is always be true. Then after we finish an operator, we go to the next one, which is not this contradicts the truth value of it inputs. So not is the unary operators. You can use it with like only one operand. In this case, you see that we can use like not true here. If you evaluate this one, it's gonna say it's false. You can also use it with like a variable. Like for this one, I define false value equal to false constant, and when you evaluate this one, it's gonna return true. And what if you use the zero value? What's gonna be evaluated in this case when you put not in front of zero? So it's gonna return true because the truth value of zero is false, right? Not false is always true. So something like this. Okay, and talking about priorities, so not will be evaluate the first always we evaluate the first one when you use it with the and all operator, but it still has lower priority than the comparison operators, which we will not cover in this video. So I'll try to show you how the priorities look like. So let's start with the evaluate not false or true. So based on what I mentioned earlier, the sequence of evaluation will be like this: not false, and then not the whole not false, and put it or true. So in this case, what's going on is gonna be like not false equal to true, or true. True or true is always true. So just like earlier, we want to show the explicit parenthesis here. So it's gonna return the same result, which is true as well. But we want to prove that this one without parenthesis just work just like this one, evaluate false, not first. So we put the parenthesis here to force it to evaluate all first. In this case, false or true is true, right? And not true returns false. Yeah, and same here for the case of and as well. When you evaluate this one, not true and false is not true returns false. False and false is false. So put the explicit parenthesis here. Okay, still return false. But what if you just put the parenthesis here and force it to evaluate and first? So true and false returns false, but not false returns true. So yeah, I believe these examples can give you more understanding about the priorities of Boolean operators. Uh, okay, so most of the time, I think not is we use it as the unary operator by putting it in front of the input. But there are some special cases that not is located at other location instead of in front of their inputs. So I think we have in the comparison operators, we have is and in comparison operator as well. So for in when you use not with is and in, you can either use it just like not one is one. So one is one will return true. When you change the not here, it's gonna return false, right? But I think it's like more provide more understanding if we use something like this. So it's more like spoken language to me. So instead of use one not and parenthesis one is one, you just put one is not one. So basically those returns the same value, but I think it's not one is not one is has provides some more sense in this case. And for in, you can use not one in a list of 1, 2, 3 as well. So it's gonna return for one in 1, 2, 3, it's return true, right? But if you add not in front of the whole statement, it's gonna return false. But it's just like the above case that we use is not instead of not one is one. In this case, we use one not n. Okay, one, two, three. So both of them return false. But I think again, this the latter is provides some more understanding. All right, I think you're pretty okay with the and or and not operator now. So the last things that I want to introduce you is any and all built-in functions. So any and all built-in function help you evaluate a list or a set of truth values. So any is like you chain several statement with or operator, and all represent the chaining and operators. So for example, in this case, if you want to evaluate like a set of uh, value, a set of truth value like this, like we put evaluate false here, evaluate false here, evaluate false here, evaluate true here, evaluate true here, and evaluate true here. So it's basically like false or false or false or true or true or true. And guess what? When you run it, it's gonna run until it finds the first true here. So, yep, as you can guess, it's short circuit again. And in this case, it evaluate like just only the first four functions. What if you don't want to have you don't want to explicitly put or in between every logical value? There's an option that you use any here. So from this one, you can turn it into this way. Uh, so in this case, it's a bit complicated that you just add a list of functions here. So it's basically a list of function. And if you're curious, what is each member of this list? So let's say we print the first member. Oh, sorry, I forgot S here. So what's actually the object here is the function called evaluate false, right? Okay, and when you use any, you have choice to use it with other type as well. But in this case, I want to show you that it's short circuit. So basically, we call any and then invoke the object, which in this case is a function. So in each element here, uh, in the iterator, it's gonna invoke the function. Like for the first one, when it evaluate this, it's gonna call evaluate false function, right? And let's say if we run this, so it's gonna yield the same result as here. I think the any and all is like very beneficial in the case that you have a list of logical statement that you want to evaluate it. You don't need to go one by one and evaluate one by one by adding an explicit or just like this. All right. So let's say you have like a range of 0 to 10, right? So basically it's the range of 0 to 10. It's like 0, 1, 2 until 9, just like this, okay? Let's say if you want to evaluate the truth value of this one, let's say a range here, all right? And you just want to know any of a range here. Okay, so it's true. What actually happens is it's just like chain 0 and or 1 or 2, something like this. So it's equivalent to this one. So on until or 9. So what actually happens is it evaluates the first one like 0 or so it evaluates 0 and returns false, right? And when you keep going, evaluate 1, 0, false, or evaluate 1 is true. So it's going to be like false or true. And whatever is coming later on is not necessary because when you chain true value with the or operator, it's always return true. So what if like we wanna evaluate any of range of 0 to 1? Okay. So basically it's gonna do something like any of the range of 0 only, right? So it returns false because the only element in the list is 0, which the truth value is false. Okay. So, and it's same for an operator as well. In this case, I chain like several evaluate functions here. When you evaluate false here, it's going to return false. And whatever is coming after that, uh, these statements, the whole statement will return false. So in this case, it will just only evaluate the first one. And you can apply it. You can transform it into the all function as well. So just like this. Okay, I believe you all are quite have more understanding about all the Boolean operators. Uh, hopefully you can get everything from these videos. And if you want to have more understanding or want to research some more, I recommend you go to the Python documentation. I believe everything are documented there. Okay, thank you all of you for watching this video. Um, just add any comments if you have any question. And thank you for today. Bye.